Hello guys, how are you today? Today I'm gonna be explaining the Chapter 7 AS Physics course revision question. So we first start with the first question, which is one grid. A force of magnitude 10 newtons is applied on a rod hinged at O as shown below. The length of the rod is 2.5 meters. They did not give us a direction. They didn't give us a convention in direction. If they didn't give us, we're not gonna put a direction. Anyways, what do we need to know about this? We know that the moment is what? Is force times the perpendicular distance. So it's the force, which is 10, times the distance, which is 2.5, times sine the angle made with the central axis, which is what? Which is 45. You put it on your calculator and you're supposed to get 17.7 Newton meter. We go to the next question, question number 2. What is the moment of a couple of forces of magnitude 50 Newton applied normally to the opposite ends of a rod of length 0.20 meters? What do we need to do in this scenario? We have a couple of forces, so they didn't give us the direction, they didn't give us the convention, so we don't need to do plus and minus in this scenario, right? So you can choose either one, either here or here to be the center of rotation. For example, I chose there to be the center of rotation, right? Now, all I need to do is, for the moment or the torque, is force times perpendicular distance. So it's my force, which is 50 newtons, times the perpendicular distance, which is 0.20. And what will I get? I will get my answer to be 10 Newton meter. This is the moment of a couple of forces of magnitude 50 newtons. We'll move on to question number 3. This came in the course practice. The diagram below shows two forces, F1 and F2, acting on a rod. Determine the signs of the torques due to F1 and F2. Here you need to apply the right hand rule. Keep in mind, when we're applying the right hand rule, the clockwise is negative and the counterclockwise is positive. So in this scenario, we need to imagine I'm gonna separate my hand into two areas, right? I'm gonna have my 4 fingers other than my thumb, and then my palm. These are the things I need to separate and focus on. For example, let us try with F1. Do you see how the arrow is pointing? It's pointing like this. So I take my 4 fingers and I make them point in this direction. Then my palm should be towards the axis of rotation. As you can see, now what would happen? My thumb is pointing towards the screen, away from me, and I'm sad because I love my thumb. So thus, it will be negative and clockwise. If you did it for F2, see, how is the arrow pointing? Like this. So your fingers need to be pointing in this direction. Where's the axis of rotation? It's here. So your palm needs to be facing the axis of rotation. So now you're left with your thumb pointing towards you. What does it mean if your thumb is pointing towards you? You're very happy, you love your thumb. That means you're gonna be positive or you're gonna be counterclockwise, okay? So F2 is counterclockwise and F1 is clockwise. We move on to question number 4. A rod is pivoted about its corner. Two forces, each of magnitude 5 Newton, act at 4 meters and 2 meters from the pivot. What is the net torque? Again, they did not ask us for the direction, okay? So what do we do in this scenario? Because it's a couple of forces, you take this to be the center of rotation, right? So now what do you have? You have the force. You need to find what? You need to find the torque of this. Torque is what? Is force times the perpendicular distance. The torque for this, because it's a moment, it's what? It's the force, which is 5 times the perpendicular distance, which is 6, times sine the angle made with the axis that intersects the center of rotation. So you could either take it as sine 30 or sine 150. It would not matter. They're both the same. And you're supposed to get what? You're supposed to get, let's put it on the calculator. 5 times 6 times sine 150. You will get 15 Newton per meter. That's question number 4 done. We'll move on to question number 5. The diagram below shows 3 forces applied at points A, B, and C of a uniform beam pivoted at end O. At which of the 3 points is the greatest torque with respect to O produced? Okay, so we need to calculate at A, B, and C the torques, and we need to see which one has the biggest torque. We first start with A. Don't forget to include the directions as well. You do the right hand rule, you will see that it's counterclockwise, positive. Then it's gonna be force times L over 4. For B, you do the right hand rule, you will see it's negative. Then it will be minus force over 4 times L over 2. For C, you do the right hand rule, you see it's positive, so plus F over 2 times L. You will see FL over 4 minus FL over 8. So let me just FL over 4 minus FL over 8, and then FL over 2. So which of the following is the greatest out of all of them? It would be C. So torque C, or like point C, exerts the greatest torque. Now we have 7.7. Interesting. Yeah, we only have until 13. Anyways, we come over here. What does it say? Question number 6, grid. Two weights, 20 newtons and 50 newtons, tied to the opposite sides of a uniform ruler can keep it in balance. The lighter weight is 70 centimeters away from the pivot, and the heavier is 30 centimeters away from the pivot. State the conditions for equilibrium and determine the weight of the ruler. What are the two conditions of equilibrium? Sigma F is equal to 0, and sigma torque about any point is equal to what is equal to 0. Now they want us to determine the weight of the ruler. We know that the weight of the ruler will be acting, because first of all it's a uniform ruler, the weight of the ruler will be acting exactly at the center, meaning here is 50, right? What does it mean? This means that this over here is 50 and this over here is 50. But how much would it be from the pivot? You just need to do basic math. If all of this is 50 until here it's 30, how much is left? You'll have 20 left, right? Because look, again, I'm going to explain it like this. This is now all 50. But then we stop at a certain point over here, which is 30 centimeters. So how much would this be? This would be 20 centimeters, right? So the distance between the weight and the pivot is 20 centimeters. So now we need to determine the weight of the ruler. How do we find that? First of all, we need to do sigma torque is equal to 0. So torque counterclockwise is equal to the torque clockwise, right? So what is the torque counterclockwise? Right? Torque counterclockwise, which is gonna be 50 newtons times 30 centimeters, is equal to the torque clockwise, which is what? Which is 20 newtons times 77 centimeters, plus the weight times 20 centimeters, right? So now, after solving, you're gonna get it to be 50 times 30, that's 1,500, minus 20 times 70, we're left with 100. So 100 is equal to 20 times W. W is then equal to 5 newtons. So the weight is what? The weight is 5 newtons. Okay, so just like that, we found the weight of the ruler. Okay, that's part B done. We'll move on to question number 7. What are the two conditions of equilibrium? First thing you need to state is that sigma F is equal to 0 and sigma torque about any point is equal to 0. This is translational equilibrium. This is rotational equilibrium. We move on to question number 8. What does it say? It says, is the following body in equilibrium? How do we check that? First thing, we need to check if it is in translational equilibrium or in rotational equilibrium. If we did the rotational first, we'll need to take the torque that's counterclockwise should be equal to the torque that's clockwise. So if you do the right hand rule, you will see that the torque counterclockwise is gonna be 2F times the perpendicular distance from the axis, which is 1 over 2L. It's supposed to be equal to the torque that is clockwise, which is what? Which is the force F times the perpendicular distance L. So basically, FL equals FL. It is, yes, in rotational equilibrium, but in order for it to be in equilibrium entirely, it should also have translational equilibrium. That means everything up equals everything down. In this scenario, we don't have any forces down. That means it does not have translational equilibrium, but it does have rotational equilibrium, okay? So the body will not rotate, it will just move upwards. We'll move on to question number 9. Okay, question number 9. A man weighing 900 newtons stands on a uniform horizontal board of length 2 meters and mass considered to be negligible. So the board does not have any mass, okay? The board is located in a vertical plane and fixed on 2 supports at its extremities as shown below. Given that the man is 0.50 meters away from support 1, what is the magnitude of the reaction exerted by support 1 on the board? There's so many ways to do this. But what's important is that you understand the general concept on how to do this. So, first of all, we should draw the weight of the man. The weight of the man is 900 newtons. Then we have the normal force 1, normal force 2. How do we find the magnitude of reaction exerted by support 1 on the board? We need to apply the equilibrium conditions. Sigma torque is equal to 0 about any point, and sigma F is equal to 0. What does it mean sigma torque is equal to 0? I will choose a point. For example, I will choose my pivot to be at 2. What would that mean? That would mean that the torque of the weight, which is what? First of all, torque counterclockwise is equal to torque clockwise, right? So what would that mean? That means the torque counterclockwise, which is 900 newtons times the perpendicular distance. If this is 0.5, how much would this be? This would be 1.5. So 900 times 1.5 is equal to the torque, which is to the torque of the clockwise, which is what? Which is the support. I'm gonna call it S1. This is S1. Support multiplied by the perpendicular distance to the pivot, which is how much? Which is 2. So anyways, you will get that S1 is equal to 900 times 1.5 over 2. So you're supposed to get S1 to be how much? To be 675 newtons. That's it for question number 9. We'll move on to question number 10. Question number 10. The figure below shows a uniform rod AB of mass m 200 grams. Because it's uniform, that means its mass is supposed to occur at the center of gravity over here, right? So this would be 200 grams, so 200 divided by 1000 times 10. I will get 2, so this 2 is how much? This is the weight, so 2 newtons. You may be like, Amanda, what did you do? I just took the mass, which is in grams, I changed it to kilograms, and then I multiplied it by 10, which is G. Okay? So now I have my weight, 2 newtons. Then they said, when a block of mass 55 grams is hanged, how much would the weight be of the block? It would be 55 over 100 times 10, which is how much? Which is 5.5 newtons. Oh, sorry, not, my bad. It's supposed to be 0.55 newtons, my bad, because it's 55 divided by 1000 times 10, that's 0.55. And then from side B, there is a force F applied perpendicularly, that means this is 90 degrees, to the whatever. The position of the pivot O is such that OB, how much is OB? OB is 2 over 3 of AB, and OA is 1 over 3 out of AB. Now, something important you need to know is that the mass, the weight of the rod is always found in the center. What does this mean? This means that this is half of AB, and this is also half of AB. So they want us to find the magnitude of F. What could I do in this scenario? Choose my pivot to be over here. They already gave it to me, but I need to know that this is very important, essential information. Right? So what would that mean? That means I need to apply that sigma torque is equal to 0, so the torque counterclockwise is equal to the torque clockwise, right? But we forgot something important. We know that the pivot will exert a normal push. If we take this point as our axis of rotation, we're getting rid of the normal push of, we're getting rid of the torque of the normal push of the pivot. So what would that leave us with? That would leave us with 2 to the counterclockwise, okay, forces. So that would be 0.55 newtons times the perpendicular distance. First of all, what did they tell us? They told us that alpha, which is this angle over here, is 30 degrees. What does that mean? That means this angle over here is 90 minus 30, which is 60 degrees. If this is 60 degrees, then we apply the U-shaped rule. That would be 180 minus 60, which is 120 degrees. Now, I have the force times the perpendicular distance from the pivot, which is 1 over 3 AB, times the angle, so times sine 120. Plus, don't forget the plus, in addition to the other counterclockwise, which is F, okay, so it would be F, times the perpendicular distance. It's already perpendicular, so times 2 over 3, 80. This is equal to what? This is equal to, so this is all of the torque that's happening counterclockwise. Now we need the torque that's happening clockwise, which is what? Which is the weight, 2, times the perpendicular distance. What is the perpendicular distance of the weight to the pivot? It's gonna be 2 over 3 AB. It's gonna be all of this. We subtracted from what? From all of this. So 2 over 3 AB minus half AB. What would this get as what would this give us as an answer? This would give us 1 over 6 AB as an answer. So 2 times 1 over 6 AB, okay, times what? Times sine, okay, where am I? Times sine the angle made with the axis of the pivot. So times sine 60. Now we just need to go into further solving. What is 0.55 times 1 over 3 times sine 120? That's gonna give me 0.159 AB plus f times 2 over 3 AB. What's 2 over 3? I'm just gonna keep it as 2 over 3. So plus 2 over 3 ABF is equal to what? Is equal to 2 times 1 over 6 times sine 60. What would that give me? That would give me my answer to be 0.289 AB. Okay? So now I can find the value of f if I cancel AB. I can cancel AB, AB, and AB. So now I have 0.159 plus 2 over 3f is equal to 0.289. Move this to the other side. 0.289 minus 0.159 would give me 0.13. So 2 over 3f is equal to 0.13. So 0.13 divided by 2 over 3, what would this give me? This would give me the value of f to be 0.195 newtons. So that's my answer for this question. We finished question number 10. For the top questions, we have question 11, 12, and 13. I'm honestly very tired and there are only 3 questions, so I think I'm going to leave them till tomorrow morning. I'm so sorry, but I managed to do at least 1 till 10, and it's a short video. Tomorrow I'll continue 11, 12, 13. They're very, not that difficult, but like when I'm more awake and I have more energy to explain. Thank you guys.